Hello and good morning, everyone. This is Manish Kumar Saha, and today we are going to learn about gravitational force. Okay, whenever we talk about gravitational force, you remember a person named Sir Isaac Newton. Yeah, you might have heard that an apple fell upon his head one day, and that day he was full of questions. Why did the apple fall upon his head? Why didn't it go upwards or any other direction? But why did it fall downwards? Okay, you might have known the answer. I guess you have guessed that it is because of gravity. Okay, let's talk about gravitational force. Gravitational force and gravity are not exactly the same thing, but they are related. Let us first talk about gravitational force. Okay, have you wondered ever why the Earth revolves around the sun and why the moon revolves around the Earth? Okay, yeah, some of you might have guessed due to the gravitation or the gravitational force. The Earth revolves around the Sun due to the gravitational force between Sun and the Earth. Similarly, the Moon revolves around the Earth due to the gravitational force between Moon and the Earth. Gravitational force and gravitation, they are the same thing. Now, what is it exactly? Let us define it, okay? Gravitation or the gravitational force is the force of attraction. It is a mutual force of attraction between any two bodies in the universe due to their mass. Anything that has mass will attract another body. Okay? So the mutual force of attraction between two bodies both having mass is said to be gravitational force. So what is the thing that causes gravitation? What is the thing that drives gravitation? It's the mass. Okay, gravitational force is the force of attraction between any two bodies due to their masses. I guess we are clear here. Yeah. Okay, so here the mutual force of attraction between any two bodies in the universe is called gravitation. But if we do not include mass here, it doesn't make any sense. For example, two pieces of magnets attract each other. That is not due to just gravitational force because that will be too small. Okay, two small magnets attract each other, but that is not due to the gravitational force. That is due to the magnetic force. Of course, gravitational force is acting upon them, but that will be too negligible. Okay, for gravitational force to be, let us say, noticeable, the masses must be pretty huge. Okay, now let us see here. Here you can see in the figure different planets are revolving around the sun. It is due to the mutual force of attraction between the sun and the planets. Let us talk about consequences of gravitational force. As I have already told you that if there was no gravitational force, then the earth would not be revolving around the sun. Okay, so here it's written here, the gravitational force is responsible for the existence of the solar system and revolution of planets around the sun. You can see it in the figure here. The gravitational force is responsible for holding the atmosphere above the earth's surface. Okay, so it is due to the gravitational force between the earth and the molecules of the air atmosphere. Okay, different gases, molecules, there is mutual force of attraction between these molecules and the earth, so the earth is capable of holding the atmosphere around it. Similarly, gravitational force keeps things firmly on the ground and stops them from floating away. So if there was no gravitational force, we would be flying. Okay, we won't need any wings to fly. We would be flying in this space, towards this space. Similarly, gravitational force is responsible for the formation of tides in the sea. So, you know, tides rise up in the sea. Yeah, it is due to the gravitational force between the water in the sea, huge mass of water, and that of the sun or that of the moon. Let us say the moon, there is a force, mutual force of attraction between the moon and the huge mass of the water in the sea. So tides of water rise up and again fall down, obviously due to the gravity of the earth. So we are pretty much clear that gravitational force is responsible for existence of galaxy and constellations. Now let us move on to Newton's universal law of gravitation. So Newton was able to formulate the universal law of gravitation when he observed the motion of the planets around the sun. Now you know that gravitational force is a physical quantity. It can be measured. Since it is a physical quantity, it can be measured. And for its measurement, there must be a formula. And to formulate that, there must be a law. And that law is called Newton's universal law of gravitation. Now, according to Newton's universal law of gravitation, the mutual force of attraction, called the gravitational force, okay, the gravitational force of attraction between two bodies in the universe is directly proportional to the product of their masses and inversely proportional to the square of distance between their centers. I repeat, the gravitational force of attraction between any two bodies in the universe is directly proportional to the product of their masses and inversely proportional to the square of distance between their centers. It simply means that if there are two bodies having more mass, then the gravitational force between them will be more. And if there are two bodies having lesser mass, then the gravitational force between them will be lesser. And if the two bodies are kept closer to each other, if the distance between them is reduced, then the gravitational force between them will be stronger. And on in the contrary, if the distance between the two bodies is increased, then the gravitational force between them will be decreased. That is why we say gravitational force is directly proportional to the product of the masses of the two bodies. Okay, directly proportional means if mass increases, the force, gravitational force increases. If the mass decreases, the gravitational force decreases. And in the other hand, the gravitational force is inversely proportional to the square of the distance between the two bodies. It means that if the distance between the centers of the two bodies is increased, obviously gravitational force will be reduced. And if the distance between the two bodies is decreased, the gravitational force will be increased. It is just like if two bodies are kept very far away, obviously there will be lesser attraction between them. Yeah. And if two bodies are closer to each other, there will be more force of attraction between them. Okay, now let us move on to derivation of Newton's law of gravitation, or you can simply say how to formulate the gravitation. In my screen, you can see two bodies, two circles, A and B. The center of circle A is O, and the center of circle B is O dash. These two bodies are separated by a distance r, as seen in the figure, and the gravitational force between these two bodies is F. And you can see the mass of the first body is m1 and the mass of the second body is m2. Okay. Now, according to the Newton's universal law of gravitation, gravitational force F is directly proportional to the product of their masses, that is m1 and m2. F is proportional to m1 into m2. Fine. And Newton's law of gravitational, furthermore, it says that the gravitational force is inversely proportional to the square of distance between their centers. So, since the distance between the centers of object A and object B is r, we can say gravitational force F is inversely proportional to r square. That is, F is proportional to 1 upon r square. Now, if these are only two relations, these are not equations, because we don't have equals to sign here. Do we have any equal to sign here? No, we don't have. Yeah, they are just relations, but we need an equation, we need a formula. Now let us see what we can do here. Let us combine these two relations. When you combine these two relations, you'll get F is proportional to m1 into m2 upon r square, or F equals to z m1 m2 upon r square. Here, when you introduce this constant term z, the sign of proportionality changes into equality. Now F is equal to z m1 m2 upon r square. This is our required formula of gravitation, where z is universal gravitational constant. It is a proportionality constant called universal gravitational constant, whose value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Now, you might be wondering, what is a constant? Now, how did this constant change the sign of proportionality into equality? Now, it's simple. Suppose cost of 1 kg rice is rupees 100. Okay, then cost of 2 kg rice will be 100 into 2. Cost of 3 kg rice will be 100 into 3. Yeah, it makes sense. Yeah, okay, so here 100 is constant. Similarly, here m1, m2 and r are variables, while z is a constant term. I think it makes clear. Now let us talk about what exactly is universal gravitational constant. From the equation above, we have come to know that F is equal to z m1 m2 upon r square. Let us suppose if mass of the both bodies is same, that is 1 kg, if mass of object A is m1 is equal to 1 kg and mass m2 is also 1 kg, and distance between the two bodies r is equal to 1 meter. In that case, F is equal to z into 1 upon 1 square, because m1 is 1, m2 is 1, and r is 1. What do you get? Z into 1 by 1 upon 1 square is z, or F is equal to z. It means that universal gravitational constant is simply the gravitational force of attraction, F, when the mass of both bodies is 1 kg and distance between their centers is 1 meter. Hence, you can say that universal gravitational constant can be defined as the gravitational force between two unit masses. Unit mass means 1 kg mass, which are separated by a unit distance from their centers. Unit distance means 1 meter distance. Okay, now let us move on to unit of universal gravitational constant. Now, you know that F is equal to z m1 m2 upon r square. If you look at this equation, if you take this r square on the other side, you get F r square is equal to z m1 m2, or z m1 m2 is equal to F r square. And if you isolate z, okay, I'm isolating z, it means I'm taking m1 into m2 to the right hand side of this equation, you'll get z equals to f r square upon m1 into m2. Now you know that the SI unit of force is Newton, and that of distance is meter, and that of mass is kg. Then what will we get? It's pretty much predictable. Yeah, so SI unit of force is Newton, distance is meter, so here instead of r square we get meter square. Here mass is kg, m2 kg, so kg into kg, that is kg square. So the SI unit of universal gravitational constant is Newton meter square per kg square. So what is the value of z? In the above equation, I have already told you that the value of G, universal gravitational constant, is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Now, in 1798 AD, Henry Cavendish determined the value of Z experimentally by using extra-sensitive apparatus called torsion valence, and he found that the value of Z was very small, that is just 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, so let us talk about the properties of universal gravitational constant. First thing, see, the value of G is independent of the medium in which the masses are placed. Okay, so two bodies, they may be placed in presence of air, in presence of water, or in presence of nothing. Let us say vacuum. In such case, also the value of Z remains same. That is why it is constant. It is universal constant. Its value does not change no matter what happens. It remains same. Okay, the value of G is independent of the nature of the masses, whether they are solid, liquid, gas, whatever. Okay, the value of G remains same. That is why it is called universal constant. Yeah, once again, the value of G is not affected by temperature and pressure, no matter whether you increase the temperature or decrease the temperature, increase the pressure or decrease the pressure, the value of universal gravitational constant will remain the same. That is 6.67 into 10 to the power minus 11 Newton meter square per kg square. The value of G is independent of the direction of the gravitational forces. Now, you know that gravitational force, okay, there are two bodies, both of them are attracting each other. Okay, so no matter which direction you take, the value of G remains the same. I think today we'll discuss this much only. If you have any questions, you can ask me. Okay, thank you very much.